Welcome to section 4.3, phase shift. In this section, we have three objectives. The first objective that we will look at states graph a trigonometric equation with a phase shift. So a phase shift occurs when a trigonometric function is shifted left or right on the coordinate plane. This happens when there is a horizontal translation in the equation of the form y equals a times sine of bx plus c, or y equals a cosine of bx plus c. So let's understand phase shifts a little bit more. A phase shift is determined by c, and it's calculated as negative c over b. So you take those values, plug it into this formula, and that then gives you the phase shift. If c is positive, then we know that the graph is going to shift left. If c is negative, then we know the graph will shift right. The function shape, amplitude, and period remain the same, but the starting point is moved left or right accordingly. Here are 4 steps that we're going to take when graphing a trigonometric function with a phase shift. Step number 1 is to first determine the amplitude and the period. Step number 2 is to find the phase shift to locate the new starting point. 3 is to plot key points at the usual quarter period intervals, adjusting for the shift. So you'll adjust your points accordingly to the shift, but continue the same pattern if it were sine or cosine. And then step 4, sketch the curve, ensuring it follows the correct direction and shape. So let's now walk through a couple problems. All right. Here we're asked to graph y equals cosine x plus pi over 2 if x is between negative pi over 2 and 3 pi over 2. So we're only graphing within this interval. Okay, so let's label that on our graph. So negative pi over 2 would be right here, and 3 pi over 2 would be right here. Okay, alrighty. So, oops, pi over 2 would be right here. I wrote that in the wrong spot. It's going by 4s. We go right here. Negative pi over 2. There we go, because it's halfway. Alrighty. So let's identify our amplitude. Our amplitude is A, the absolute value of A. In this case, it's going to be 1, and the absolute value of 1 is 1. Our period is going to be 2 pi over the absolute value of B. So that will be 2 pi over the absolute value of 1, which simplifies to 2 pi. And then our phase shift, which is our new transformation, is going to be negative c over b. So that would be negative pi over 2 divided by 1, which is negative pi over 2. So that means the cosine parent function graph is shifted to the left because this is negative by negative pi over 2, sorry. So it's going to move left. Okay. All right. So we know our amplitude is 1, which is the same as the parent function for cosine, so that doesn't change. And the period is the same as well. So in the parent function for cosine, we start at 1 on the y-axis. But since we are shifting over to the left, pi over 2, we're now going to start at the point 1 on the y-axis and then negative pi over 2 on the x. Let me do our little highlighters here like last time, just so that you can see it a little clearer. All right, okay. So we're going to start at 1, and then we'll continue the pattern. So the y then goes to 0, and then it will go to -1, then 0, and then 1. Then we can connect those dots. All right, and we now have our graph. Let's do another one. All right, so here we have y equals 4 times cosine 2x plus pi over 2, and we need to graph between negative pi over 4 and 3 pi over 4. So we know our x-axis goes by pi over 4, so negative pi over 4 would be located right here, and 3 pi over 4 would be located right here. Okay, so let's find some key information. We'll first start with our amplitude. So our amplitude is going to be 4. Our period is going to be 2 pi over the absolute value of 2, which then gets us pi. And our phase shift will be negative pi over 2 divided by 2, which equals negative pi over 4. So in this case, we are also moving to the left, pi over 4. Still working with the cosine graph. Okay, so our amplitude here now is 4 instead of 1. So this is very similar to the last graph. All right, except for our interval has changed. Our period is now half of what it was before, and our phase shift is now pi over 4 instead of pi over 2. Okay, so at negative pi over 4, we're going to start at 4 on the y, so we'll start up here. So instead of skipping 1 like I did in the previous problem, I now have to go every other next unit. So for example, negative pi over 4 is where I started, and so now I'll go to the next x-axis value, which would be 0. And then I'll plot the next y, which will be 0. And then I'll go to pi over 4, which would be 4. And then pi over 2, which would be 0. And then 3 pi over 4, which would be 4. And so now I can connect my dots. It's disappeared. Okay, alrighty, awesome. Okay, so now we're working with a sine graph. So we have y equals 3 times sine of 2x plus pi, and we're working between negative pi and 2 pi. So both of those values are already on the graph here, which is great. So let's find our amplitude. Our amplitude is going to be 3. Our period will be 2 pi over the absolute value of 2, which will be pi. And our phase shift will be negative pi over 2. All right, so this will move to the left by pi over 2. Okay, and we want to graph between pi, and 2 pi. Now we're doing the sine graph. So this one's a little bit different, but we know the sine graph starts at the origin and then it goes up to 1 and then down to 0 and then -1 and then it continues the process. Okay. All right. So let's plot some points. So for negative pi, we're going to start at 0. Then we're going to go down to 3. All right, and we'll go down to 3 here. And then we'll go up to 0. And then we'll go to 3. Then we'll go to 0. Then we'll go down negative to -3, then to 0, up to 3, down to 0, -3, 0, 3, 0. Okay, and so now we can connect the dots. Okay. Oop, I missed that point there. There we go. All right, so we've graphed between negative pi and 2 pi. Okay, and our graph was shifted by negative pi over 2, and our amplitude was 3. All right, now let's go into our second objective. Graph a complete cycle of a trigonometric equation. So a complete cycle of a trigonometric function represents one full repetition of the pattern. So the period of a function tells us how far we need to go along the x-axis before the function starts repeating itself. So in understanding a complete cycle or one full rotation, you need to know that for sine and cosine, one cycle spans a length of 2 pi, or a modified period if b is present in your function. For tangent and cotangent, one cycle spans pi. The function then returns to the starting position at the end of the period, so going from 1 to 1 or 0 back to 0. So here are 4 steps to graph a complete cycle. You'll first find the period using p for sine and cosine, 2 pi over the absolute value of b, and then for tangent, you'll utilize pi over the absolute value of b. Then you'll determine key points. So that's going to be the starting point, the quarter period points, and the end of one complete cycle. Again, continuing the pattern that is known for each of these trigonometric functions. Then you'll plot the midline and amplitude to shape the wave, and then sketch the full cycle, repeating the pattern at the correct intervals. Okay? All right. So our first example here asks us to graph one complete cycle of this trigonometric equation. So let's first find the amplitude. So the amplitude is going to be 1 in this equation. The period is going to be 2 pi over the absolute value of b, which is 1. So that'll be 2 pi. And then the phase shift, because we have c present, is going to be negative times negative pi over 4 over 1, which then just gets us pi over 4. Okay? So our complete cycle of sine, our one full rotation of sine, is going to be shifted to the right pi over 4. Okay, so our sine graph would start at 0 and then go up to 1 and then down to pi and then to 1 and then back to 2 pi. But now we're going to take this and shift it over by pi over 4. Okay. Okay. All right, so let's start at pi over 4, which means it's going to go all the way to 9 pi over 4. Okay, and I'm going to start at 0. Oop, let me do the highlighter again. Start at 0. And then I will skip 2 and go up to 1 because my amplitude is 1. Then I will go 0, -1, and then I will go to 0. Okay. Then we connect our dots, and that is one complete cycle. All right, let's do another one. Still working with sine. Okay. Our amplitude is going to be 3. That's what's being multiplied by sine. Our period is going to be 2 pi over the absolute value of b, which is 3. So that'll be 2 pi over 3. And our phase shift will be negative times a negative pi over 3, which is pi over 3. So if we were to graph this function, we would move to the right pi over 3. Okay? But since we're only doing one complete cycle, we're going to start at pi over 3. And since the period is 2 pi over 3, we would only go 2 additional pi over 3s, if that makes any sense. Hopefully it does. But I'll re-explain it for you. So between 0 and pi here on my graph, it's broken into 4 different parts. So I need to now re-break up. I need to re-break up? No. I need to identify where 1/3 or pi over 3 is located, as well as 2 pi over 3 is located. Okay, so I'm going to go right here for 1/3, and then here for another third, and then I would land at pi. So this would be pi over 3, this would be 2 pi over 3, and then pi would be 3 pi over 3, which is just pi. Okay, so I know that a whole period is going to happen within 2 pi over 3. And my graph shifts to the right pi over 3. So if I was just drawing this originally, I would be starting at the origin. But since my graph is shifted, I'm now starting at pi over 3. So that's where my 0, or my point that would have been 0, 0, is now located. Since my amplitude in this case is 3, my next value is going to be 3. So that's going to be halfway in between pi over 3 and 2 pi over 3. Let's just mark that. And then I'll come back down to 0, and then halfway in between 2 pi over 3 and pi, I'll go down to -3, and then to pi, I'll go back to 0. Okay? And this is one full, let me redo that. This is one full cycle for cosine, this cosine function. Okay, all right. Okay, next one, we're dealing with cosine. Our amplitude is 3. Our period is 2 pi over 2, which is just pi. And our phase shift is going to be negative times a negative pi over 4 over 2. All right, and that will equal pi over 8. All right, so we're moving right. So we have a shift to the right by pi over 8. Since our graph goes by pi over 4, I know half of each unit is going to be pi over 8. So that means this half mark here will be pi over 8. Okay? Since I'm shifting over pi over 8, I know for cosine, one complete rotation or cycle goes from 0 to pi. So I have to shift over pi over 8 from pi, which will get me 9 pi over 8 as my x coordinate, because I'll be shifting that graph over to the right by pi over 8. Okay, so for the cosine graph, I know I start at my amplitude. So in the parent function, I started at 1 because that was the amplitude. In this case, it's 3. So for pi over 8, I'm going to start at 3. And I know I'm going to end at 3 for 9 pi over 8. Okay, so halfway in between these 2 points is going to be negative 3. Okay, and then halfway between the halfway mark, so the first point and the halfway point is going to be 0. And then the same thing from the halfway point to the last point, it will be 0. Okay, and then I'm going to connect my points. And that is my graph. All right, our third objective is to graph a trigonometric equation with a vertical translation. So a vertical translation just shifts the graph up or down by a certain amount, changing the midline of the function. So this occurs when the equation has a k value as seen in these two equations. So now we're adding, or I guess you could say subtracting, a value. So the midline is going to move up by k if k is greater than 0. In other words, it's positive. The midline will move down by k if k is less than 0 or a negative value. The amplitude remains the same, but the entire function is then shifted vertically. So I have some steps here for you. You'll notice that they're very similar to the other steps provided. I've just added in a couple more just for the vertical translation. So we're still going to identify our amplitude and our period, but then we're also going to locate the new midline, which is going to be our k. Then we're going to shift the entire function up or down to match that new midline, and then plot key points at the quarter period intervals or the third period intervals, whatever the graph tells us. And then we're going to sketch the graph, ensuring it follows the proper wave pattern relative to the new midline. Okay, so let's first graph this function. I believe this is problem number 6. We have y equals 4 cosine times pi x plus pi over 3. Okay, so our amplitude will equal 4. Our period will equal 2 pi over pi, which then equals 2. Our phase shift will equal negative pi over 3 over pi, which equals negative 1/3. So we're going to move left. Okay. So similar to the last problem, we know we're going by thirds. So I'm going to break up my axis into thirds so that it's a little bit easier for me to graph. So I'm going to have a value here, and then pi, a value here, and then here, and then 2 pi, and then I'll have 0, value here, here, negative pi. Okay. I know my period is going to be 2. I know my amplitude is 4. And I know my phase shift is negative 1/3. Okay. So since my period is 2 and my phase shift is negative 1/3, you can kind of think of my axis as whole numbers. So instead of pi, it would just be 1. Instead of 2 pi, it would just be 2. Negative pi would just be negative 1, and then negative 2 pi would just be negative 2. So I'm just dropping the pi because they got eliminated when I found my phase shift. It doesn't change the process of the graph, it's just the axis is a little different. Okay? So I am now going to plot my points. Okay? Since I know I have a phase shift of negative 1/3, that means I moved to the left by 1/3. I'm going to start there and I'm going to go a whole period of 2. All right, so my period or my complete cycle rotation must happen within 2, or in this case 2 pi, although my period isn't 2 pi. All right, so we're going to start at negative 1/3, which will be this location. Let me label that negative 1/3, which is technically negative pi over 3. But remember, my axis is in pi, but if I were to just write it as whole numbers, that's what it would be. And I want to go a complete 2 pi. So that means I'm going to end at 5 pi over 3 because I shifted by 1/3. So technically it's not 5 pi over 3, it's pi over 3. No, pi over 3. 5 over 3. It's 5 over 3, which is the pi over 3 location. Yes, I guess that can be a little confusing. I'm sorry about that. All right, now let's plot some points. Okay, so negative 1/3, we're going to start at our amplitude, which is going to be 4. And we know we must end at 4. So the halfway mark must be negative 4. And then we know in between the halfway and the 2 endpoints must be 0. Okay. So we know halfway mark, which will be here, is going to be 0. Okay. And then the halfway mark here, between those will be 0 as well. If you want to do the points in between those, you can as well. So for instance, 0 would be 2. What else? The 4 over 3 would also be 2. And then we would have 2 over 3, or 2 pi over 3 in this location, would be negative 4. Okay, yeah. So then halfway in between that would be negative 2 and negative 2. So pi would be negative 2. All right. And so then we can plot. All right. And that is our graph. So now let's add on a vertical translation. And our vertical translation here is going to be the value that's either added or subtracted. So let's rewrite our equation as y equals 4 cosine pi x plus pi over 3 plus 2. So we know that our vertical translation is going to be plus 2, which means we are going to move up 2 units because our k here is positive. So we're going to take all of the values that we just plotted in the previous problem, and we are going to add 2 to the y. Okay, so we're still starting here at, not right there. No. We are starting by breaking this up into thirds. Okay, so -1. And then I go all the way to 5 over 3. Okay. All right. And we're going to move up. So our first point was at -1/3, 4. And so I'm now going to move up 2 units. So now I'm going to be at -1/3, 6. Okay, which is not on the screen, so we're just going to plot the point up above because the y-axis goes by increments of 1. Okay, and then I know I'm going to end at 6 as well. Okay, my middle point, which was at 2 over 3 or 2 pi over 3, was at -4. So now this value is going to go up 2, so it's going to be at -2. And so then I can mark the halfway points. Okay, so I know that on the y-axis, I was at 2. So I'm going to go up 2. So now I'm going to be at 4. Then I was kind of halfway in between 0 and 1 over 3 or pi over 3, which would have been pi over 6. And that was at 1, so now it's going to be at 2. And then for 1/3, that was at -1, and so now that would be at 0. And so now I can replicate this on the other half of my cosine graph. Okay. So this would be 0, and then I would have 2, and halfway up here, 4. There we go. You just follow the same pattern, and then you can connect your dots. All right, excellent. Well, that concludes section 4.3.